Hi there, and welcome to this section about creating apps. In this section, we will cover how you create end-user applications, which is really what end users will use. So, to be convenient and easy for you to get started, we have a number of app samples. We have a simple app, which is called the Guestbook New app, and we have a slightly more advanced version, which is called Guestbook Helm, which uses Helm charts, which is essentially a templating engine for Kubernetes. However, in this section, we'll cover just the simple version. The only thing you need to do to deploy an app is really to copy the sample application. So you copy the Guestbook New and rename it to your own naming convention, whatever you would like to call your app. And then you commit it and push it, and that will create your app for you, and nothing else is needed. However, as always, the devil is in the details. So here we're going to dissect an app and look at what is inside. First of all, it's good to know that an application has two parts to it. It's the generic part, which covers all the internal parts, like the engine details, which has nothing to do where it's deployed. And the other part is the deployment-specific parts, where it's deployed in a cluster, where you specify things like DNS names, SSL certificates, and internal cluster setups. So we're going to start deploying the generic parts in one of our clusters. And to do that, we use something called custom resource definitions. And we use that together with Argo CD's version of them. So we start by looking at Guestbook New Terraform script. And this lives within cluster, app inventory, and Guestbook New. This is the cluster specific part of the deployment. What we do here is that we specify where the generic part lives and what we want to deploy. So as you see in the middle here, we pointed to a Git repository and a specific path within the Git repository. All we really do here is that we point the application we're deploying to this part of the repository, which is called apps. This will then be deployed in the cluster under the new name Guestbook New. So let's see what this looks like when we commit and push it. Now we have it running in the cluster itself. And if we go into the Argo CD GUI, we can see that we deployed a number of internal parts to the application. In the very core part, we have a pod running the Docker image. We have a replica set that controls how many number of pods we have. We have a deployment specifying what is running, what image is running. We have a service that says how to locate the application itself. However, this is not reachable from the outside just yet. So in order to see this application, we need to dig into the cluster itself by exposing the application through something called port forwarding. Port forwarding is what you see down here. It's basically pointing our browser towards a service directly in the cluster. This is obviously not the way we want to have it in the end, but this is a debug way to see the application running initially. By doing this means that we can expose the same port that is running internally in the cluster on our local machine. So this is now looking like this. This is the very simple application called the Guestbook application. It doesn't really do anything else but shows how to deploy an application. And you're running on localhost. It is just pure HTTP, so nothing fancy around it. But in order to deploy this so it's visible from the outside, what we need to do is to expose it to the outside world. And to do that, we use something called an ingress. An ingress is really just like what an Apache vhost used to be in the olden days. So it's basically a proxy that takes a request from the browser. It routes it to what is called an ingress, and that points it to a service we already have deployed, and that points it to a number of pods. So in order to deploy this ingress, we do that in the same way with Terraform. So looking at the same file, we have an ingress specified here. And this essentially allows the browser that is pointing to the environment to route into the internal service. In addition to that, we also like to have SSL encryption to keep everything secure. And in order to do that, we use something called certbot. Certbot is basically a system to get free SSL certificates from Let's Encrypt. All it does is enable this little icon up in the corner that indicates that we have a secure site, and all the communication across the network is encrypted. In order to get this running, it's very simple, and all we need to do in the configuration is to specify that we want to use it and that we have certificates available here. This will automatically provision certificates in the background, and it will also renew certificates every 60 days with Let's Encrypt. These certificates are only valid 90 days, so this will be a common activity that happens in the background that is good to be aware of, but it's nothing that you need to do yourself. And in the final stages, once this is deployed, we can see the application running in the end. And what we here see is that we have our cluster name specified, have the DNS names specified as new.guesswhat. Our cluster name and our domain name. We have it all secure, and we have it running with not more than a single commit. So this is all for now.